Okay, so in this video, I'm going to show the proof for this identity. So we wish to prove that cosecant theta cosine theta over the secant theta sine theta is equal to the product of 1 plus cosecant theta minus 1. Okay, so when we prove identities, so let's start. Okay, let's say proof. You have to choose between the two sides, either the left hand side, so this is the left hand side, or the right hand side. In most cases, you have to choose the one that is more complicated. Although this particular identity, you can have the left hand side or the right hand side as an option. I will prove this using the left hand side. Okay, so my proof will start this way. So I'll be picking the left hand side. So cosecant theta cosine theta is equal to secant theta sine theta. Okay, the idea behind is that we wish to end with 1 plus cosecant theta times cosecant theta minus 1. So as you can see, there is no addition or subtraction involved on the left hand side. So that is what we're going to create. Okay. In proving identities, it is always helpful to change all the other functions into sine and cosine, meaning this cosecant theta should be changed into sine or cosine. At the same time, secant theta should be replaced by a sine or cosine. Now do not touch cosine and sine anymore because they are already expressed as cosine and sine. Okay, so you have to recall certain identities, like what is cosecant theta equal to? So we know that this is 1 over sine theta. Secant theta is 1 over cosine theta. So in your proof, the next step will be, it will become 1 over sine theta, then you copy cosine theta, and below it's 1 over cosine theta times sine theta. Then you proceed accordingly. Now, the numerator should become cosine theta over sine theta, while the denominator will become sine theta over cosine theta. Okay. Now, when working with fractions, involving fractions, this is the same as cosine theta sine theta. That's your numerator. And this will be multiplied by the reciprocal of this. So cosine theta over sine theta. And this will become cosine squared theta over sine squared theta. Then we have to think of ways on how we can come up with cosecant theta. Okay, this is a bit tricky because we are going to change this into cotangent squared theta. Now, cotangent squared theta is related to cosecant theta, okay, by a certain identity. And that identity is cotangent squared theta plus 1 is equal to cosecant squared theta. Okay, now I'll take you back to the one that we're trying to prove. Okay, we wish to create 1 plus cosecant theta times cosecant theta minus 1. Okay, now if you look at the identity, you see the 1 here, you see the cosecant. So somehow, you could make this cotangent squared theta equal to cosecant squared theta minus 1. And you're very close to what we are trying to prove. So in our step here, cotangent squared theta should be replaced by cosecant squared theta minus 1. Now, I hope that you could see this as an algebraic expression in some way, because you can actually factor this into cosecant theta minus 1, cosecant theta plus 1, which is almost the one that we need. Okay? So this is exactly this, and this is exactly this. So all you have to do is to do some rearrangement. Cosecant theta plus 1 is equivalent to 1 plus cosecant theta. Okay, commutativity. You can interchange. And then the cosecant theta minus 1 as the second product. And that's what we are trying to prove, that it will be equal to this. So hence, we were able to prove that the cosecant theta cosine theta over secant theta sine theta is equal to 1 plus cosecant theta times cosecant theta minus 1. Okay, so that's the end of the proof.